In this tutorial, I'll show you how to use numeric data to train a deep neural network. Numeric data means the training features on numbers. We will learn the process through an example of diabetes prediction. That means after training, our deep neural network will be able to predict diabetes. To keep our work organized, create a folder and name it Diabetes Prediction. We will keep our code and dataset in this folder. This is the dataset. I'm dragging it in this folder. You can download this dataset from the link given in the description below. Let's have a look at the dataset. These are the features. Based on these features, the last column, named Result, concludes if a patient is diabetic or not. That means this last column contains the classes we want to predict. Now launch your MATLAB. Click on this Browse for Folder icon and locate the working directory. Then select this folder. Now we can see the dataset in this current folder window. That means we are in the right directory. Now we need to load the dataset. For that, we are going to create a function. And in MATLAB, function starts with the function keyword. We want our function to return the dataset and the classes. The name of our function is load_dataset and the parameter is file name. Then type end. So the function has been defined. Now use the readTable function to read the dataset. The first argument of this function is the file name. The type of the data we have in this file, that means text type, is a string. Finally, we are going to store the dataset in a variable named dataset. So this function will read the dataset and will store it in this variable. Then declare a variable named classes. We have seen from the dataset that the name of the last column is result, which contains the classes we want to predict. Therefore, the classes is result, which is the last column name. Now there is a problem here. What we have in the last column are texts. We need this text as category. One is yes category and other is no category. Luckily, it is very easy to do it in MATLAB. There is a function named convertVars, which converts text into category. The first argument of this function is the dataset, and the second argument is the column name we want to categorize. We want to categorize the result column, which is stored in the classes variable. The last argument of this function is categorical. With this value, we are telling this function to convert these classes into category. Finally, store the returned dataset in the dataset variable. Now, in this variable, these yes and no are no longer text, they are categories. If the dataset is not empty, then display dataset has been loaded. That's all. Our function is ready. Let's save it. The name of the file and the function name have to be the same, otherwise it will not work. Let's run it on the command window. The name of the file is diabetes.csv. Hit enter and we can see the classes and the dataset are here. That means the function worked properly. Now it is time to build a function for data processing. We want the training data, validation data, test data. The list is getting longer. Let's use 3 dot and jump to a new line. We want number of features and number of classes from this function. Using three dots to go for another new line, let's name this function data underscore processing. And the parameters are dataset and the classes. Use the end keyword here and the function has been defined. The first thing we need to know the name of the classes. Go to the command window and declare a variable class underscore names. Then use categories function. The argument of this function is the dataset. Now in curly brackets, write colon, comma to get the columns only. And we want the classes column. Now hit enter and we can see the class names are yes and no. Now copy this line and paste it in the function. The next thing we need is the number of data we have in the dataset. Again, go to the command window, declare a variable named number underscore of underscore data and use the size function. The argument of this function is the dataset. Hit enter. We can see there are 768 rows and 9 columns. That means there are 768 data instances. We do not need the column information here. Press the upper arrow from the keyboard to get the previous code back. Now add 1 here, separated by a comma. Hit enter and we've got the number of data instances of our dataset. Let's copy this line and paste it in the function. Now we need to find out the number of training, validation, and test data. Use a variable t, then multiply 0.7 with the number of dataset. It means we're taking 70% of the data for training. Hit enter. There is a problem here. It is a fraction. The number of data instances has to be an integer. Let's use the floor function to round this number to the floor. Now it's fine. So we will use 537 data instances for training. Let's do the same thing for validation. Use the upper key to bring the previous code back. Change this variable to v. We will use 15% of the data for validation. So make it 0.15. And we can see we are going to use 115 data instances for validation. Now use a variable ts, then subtract v from t. It gives us the number of test data instances. It is 422. Now copy these lines and paste them in the function. So now we know the number of training, validation, and test data. However, we have to randomly pick the data. So define a variable named random, then use the randparm function. The argument of this function is the number of data. This function will randomly generate 768 random unique integers. That means there will be no fraction and no repeating of the same number. Define another variable random underscore train. Then we are going to randomly select numbers from 1 to t. After that, use another variable random underscore val for the validation. And we're going to pick numbers randomly from training to validation number. Use another variable random underscore test. And we are randomly storing numbers after training and validation number till end. To understand what are happening here, let's copy these lines and paste them in the command window. Hit enter, then type random and hit enter again. We can see a lot of random numbers here. Let's use the size function and take the random as the input argument. We can see there is one column and 768 data. Let's get the number of data only by putting 2 here. So this random variable has 768 random numbers which refer to the data instances of our dataset. The random underscore train variable contains 537 random numbers. There are 115 random numbers in the random val and 116 are in the random test. As we have the random number for training, validation and test data, we can randomly select the data. Define a variable named training data and then from the dataset pick training data row randomly. Here, this empty column means we are not using the columns. We are using one row at a time. Do the same thing for validation data and the test data. Let's copy and paste it in the command window to see what it does. We can see the training data. These data have been selected randomly. Now on the command window, use a variable number of feature. Use the size function to get the number of the dataset. This time we are interested in columns only. That is why using 2 here. Because the columns represent the features. We can see we have 9 columns. The last column contains the classes. These are not the training features, so -1 from here. And now we have the number of features stored in the variable. Copy and paste this line in the function. Next, we need the number of classes. Use the numl function to find the number of elements we have in the class names variable. It is 2. We already know it. They're yes and no. So copy it and paste it in the function. Finally, save the function as data underscore processing. Remember, function name here and here must be the same. Otherwise, it won't work. So this function takes the dataset and the classes as argument and returns the training data, validation data, test data, number of features, and number of classes. Let's copy it and paste it in the command window, then hit enter. We can see it returned the expected values. That means everything worked perfectly. Now we have a function to load the dataset and there is a function to process the data. It is time to build another function to design the network. So create a new script and start with the function keyword. We want the layers and the training options from this function. The name of the function is network underscore design and the parameters are hidden layers. It means number of hidden layers. Then use 3 dots to go to a new line. The next parameter is number of classes. After that, the validation data, the number of feature. Again, going to a new line and mini batch size. This function requires these arguments. Use the end key and the function has been defined. Save it as network underscore design. Now declare a variable named layers. Then use the square brackets. Here we're going to define the network architecture. The first element here is the feature input layer function. The arguments of this function are number of classes, then normalization is z-score. It means we're using the z-score as the normalization parameter. Now we need to specify the number of fully connected layer. The argument of this function is the hidden layer. That means this function creates the hidden layer for us. After that, we need to use the batch normalization layer, then a ReLU layer. Finally, another fully connected layer, which is actually for the classification. That means the input argument is the number of classes. Then use a softmax layer followed by the classification layer. And we are done. The network layers have been defined. The next task is to specify the training options. Let's use a variable named options. Then use the training option function. The first argument of this function is the learning algorithm. We are going to use the ADAM, which is the short form of Adaptive Moment Estimation Algorithm. Then the mini batch size, and it is in the mini batch size variable. We want to shuffle the data in every epoch. The validation data are in the validation underscore data variable. We want to plot the training progress, and we do not need any verbose. So these are the training options. Our network design function is ready. Let's copy it and paste it in the terminal window. The number of hidden layers, say 50. You can use any other value. It depends on how many hidden layers do you need. Then I'm using the mini batch size 16. You can use other values. It's totally up to you. Then hit enter. After that, use the analyze network function and pass the layers as argument. Hit enter. And we can see the network architecture. It is a plain and simple architecture. Now create a new script and save it as main or any other name you want. We want to load the dataset here. So copy load underscore dataset function and paste it here. The argument of this function is the diabetes.csv. Then we want to process the data for training. We already have the function for that. Copy it and paste it here. Next task is to design the network. So use the network underscore design function, and we're going to use 50 hidden layers, and the mini batch size is 16. All set. Now we can train the network. We use the train network function to do it. The first argument of this function is the training data. Second argument is the classes. Third argument is the network layers. And the last argument is the training options. This function returns a trained network. Let's store it in a variable named net. So it is time to write the code to test the network. Declare a variable named predicted and use the classify function. The first argument of this function is the net. Second argument is the test data from first to last column. Then the mini batch size is 16. So this function will use the trained network to classify the test data, and then it stored the result in the predicted variable. To compare the result, we need to find the actual label of the data. To do it, use another variable test underscore data. Then read the classes from the test data. After that, declare another variable named accuracy. Then use the sum function. If predicted is equal to the test data, then it is a correct prediction, and thus this function will add it up. Then divide it with the number of elements we have in the test data using the numl function. Finally, use figure, then confusion chart function. The first argument of this function is the test data, and the second argument is the predicted variable. It will generate a nice confusion matrix. That's all. Run the program. We can see the training process has started and it is in progress. The training is completed and we have got 77.39% accuracy. We can see the true and predicted class on the confusion matrix as well. And this is how you can use numeric data to train a deep neural network.